Hello, it's Steve. Last time we set up Bevy and row XML tree, or read-only XML tree. Today let's go through the process of loading this data in the Bevy way rather than as a constant string. And the way that's done is through something called asset loaders. So let's jump right in. First thing I'm going to do is just get this string out of our way. It's a little bit obnoxious, but I want to keep this variable around so we don't get extra errors for a little while. And before I launch too far into this, let me just talk about some research I did around this. Most of what I'm talking about today is going to be based on this example from the Bevy examples repo. Here they're using asset loaders and some other things just to load in some basic text files and transform them, which is really not too different than what we're doing. So this is a perfect example for our cases. I'll leave this link in the description. To start off with, let's go ahead and add the default plugins. And so default plugin is going to be a lot of the, say, like the window and a few other things. I'm sure there's documentation somewhere on what this all sets up for you. But one thing is we need to add the asset plugin to this. So let's do set asset plugin. And that takes some properties. This is just to make our paths to our maps and other things a little bit smaller. We're just going to do this to res, since that's the root folder of all of our resources. Just makes sense. And that takes a string. And since this implements default, we can do default like this. And that grabs the rest of them. Whatever else is in asset plugin. So that's all we really need to get the asset loaders configured. So let's start implementing them for our use case. First of all, we want an asset to save our map data in. So we're going to call this struct map. And we're just going to use a string for now as the data because we're really just trying to keep this simple. And this derives asset type path and debug. Cool. So that's the asset we're going to be loading, but we actually need to implement something called an asset loader. And we need to actually implement that for something, which means we need a empty struct. We'll call that map load settings. Or actually, not map load settings, map loader. And there's the struct that it's defining it for. And this also needs a few traits. That's clone, default, serialize, deserialize. All right. So those are the things we need for that. Of course, my cargo check is running right now, so I don't have very good IntelliSense. So this should be yelling at me. There it goes. Aha, we can't find asset loader. I need to grab that from somewhere. Let's check. Oh, look at that. Default plugin is also mad now. Ah, oops. This should be default plugins. That's why. There we go. That's happier. Let's do a use Bevy asset. And we're going to grab a few of these. IO reader, asset loader, which there's that. Async read ext, load context. Some of these are things that we're going to need later, but let's see how that feels. We need serialize and deserialize, so let's use, these are in srd, but it looks like we're going to need to add srda. So let's go ahead and chuck that in while we're at it. Cargo add srd. There we go. And once that figures out what it's doing down here, that'll be a bit happier. I don't know why I put an H in async. That's great. Error kind. And also standard IO error. That should be happy. First, let's go look at this red squiggle. This is saying we need the type asset, we need the type settings, we need a type error, we need a function load, and although this is still loading, we need one more function as well. So let's start from the top. Let's add a type asset. I believe this can just be settings, but we might need to define our own settings type for this, even though we're not going to use settings at all. I know type error can just be error. That's totally fine. Async, function, load, lifetime, a, parentheses, body. All right, what does this call? What does this take? Well, based on the example, let's just go ahead and copy directly from the example here, because some of these types are a little bit arcane. Pointer to lifetime a, self. That's super easy. Reader is going to be pointer to lifetime a, mutable, reader. Wow, you don't say. With some lifetime that we don't care about. Settings, which I don't care about personally, which is why I'm putting an underscore there. Lifetime a, map, load, settings, as well as load context, which I don't believe we need right now. Mutable, load context, with some lifetime that no one cares about. Cool. Next up, that's going to be returning a result of type map, which is our asset, and error, which is our negative result. Let's look at this and see if our IntelliSense is kept up yet. No, but looking into the example, there's one more thing we need. So this is going to be the extensions of the files that trigger this asset loader. So right now, all we care about is TMX for this. I called this the wrong thing. And it looks like we do actually need... Oh, actually, can we just do self? Or is this... That doesn't make much sense. I don't think we can do this. Yeah, we're just going to make our own type even though we're not going to use it. And I realize now that I put this in the wrong dang spot. There we go. Now the only issue is the body of this and a semicolon. Cool. Alright, into the body of load. So what we're going to do here is we're going to read from the reader. And we got to put that in something. So let's grab a lat mute bytes. So there's a new mutable vector of bytes. And that's what we're going to be reading into. This returns a read to end future, which we need to await for. So let's await it. And then this returns a result with the size or an error. We don't really care about the size right now, but we can use a question mark to bubble the error up to the return of this load function, which will be fine. Which means now we can be reasonably confident that this bytes array is filled. So let's try and read from it. First of all, I rather read from a string. So let's do string from UTF-8 bytes. And that returns a result. So let's go ahead and match on that. Now, the reason we're not bubbling this up directly is that this error is of a completely different type than what we have, so we have to make a new one. This one took a little bit of research to figure out. Okay, weird interaction there, but whatever. I bet there's a better way to do that error handling. I'm sure I'm doing this that is in the dumbest way possible, but it works. And value is going to be a string. So let's return OK with a map and this string. It takes a second for the dev tools to catch up, but hey, we're happy. Okay, so this is going to be loading our data directly into the map. As you can see, the map loader actually isn't being referenced yet. So let's go to the top here, and we're going to do two things to make sure this actually happens. We got to init our asset. This just registers the asset as something that we could be asset loading. And we're also going to register our asset loader itself. So there we are. That creates a new map loader with these functions on it that it can then use as it sees fit. So we have our map loader, which can load maps. How do we actually get that process started? Well, let's go look at our setup function. I'm actually going to save this chunk for later, and you'll see why in a little bit. But let's just put it in a little comment and pretend it doesn't exist. To start with, let's grab the assets server. This is a Bevy thing. It allows us to do calls to load assets. Dot load, and then a path to the thing that we're loading. We're just going to hard code in a path to our tutorial 0 TMX. That's this one right here. And since I put res here, that's just going to be maps tutorial 0 TMX. Now, what does that return? That gives us a handle. So we actually need a place to save these handles, which is a good use of resources. So let's make a resource. Derive resource struct map handles. Maps. And in this struct, we're going to have a vector of handles of maps. And at some point, we might want to break this up differently. Maybe we want to have a different chunk for each world in these map handles. For now, I'll just do maps. That works. And of course, we also need to add these map handles to our world. Now, we could do that theoretically up here. Now, in a lot of cases, this is what you'd want to do for a lot of resources that you want to insert. But since our resource depends on running this map asset loader, we actually have to do it in here. And the way you do that is to have immutable commands. And then from that object, we're going to call insert resource and make a new map handle IDs, or map handles. Map handles? Is that what I called it? Yeah, it's right there, staring me right in the face. And for that set of maps, let's make a new vector. And that is actually what we're going to be putting this in. And that's a vector size 1, and index 0 is always going to be the handle to this map. Now, we've loaded in our maps. Let's actually try to read the data. To do that, I'm actually going to make another system. Call it hello assets, why not? Let's be cute about it. Which we're going to take our map handles resource, as well as our set of map assets. So you might be wondering about how we can just make these systems referring to things and never pass them in. If you're familiar with dependency injection, it's practically pretty similar to that. Just something that Bevy handles behind the scenes. And that's kind of the reason we have to define these with very specific traits, is that it'll allow Bevy, the engine, to know what and where to pass this information. Another thing you might notice here is that, well, if we just have this set of assets, really we can use this like a list. We can have, I believe there's an iter, yeah, you can use an iter or an iter mute to just grab all of the active map assets, and we could do that, but then we'd have to basically parse into each one and check what it's called. Basically, we could basically add a property onto here somewhere, right? And then instead of having to do all of this map handles shenanigans, which of course I named wrong again, we would be able to use that data to save it in. That's a different way to do it. It's not the way I'm doing it here, but it's a way you could do it. Maybe it's a way you could try doing it to kind of deepen your knowledge of how Bevy works. So now let's try and use this data. The way we use these two objects in tandem is that we take our map assets and we call get, which takes a handle, or really it takes something that can be turned into an asset ID, which a handle can be turned into an asset ID. So we grab our map handles, give it a reference to map handles dot maps at 0. So that's the first map, which is the only map that we currently have. Now you might be wondering, okay, well, how do I know that this has anything in it, or it even exists? Well, it's only going to pass this in if this resource exists and is registered. And when this resource is registered, it's only registered in one place and with a index of 1. So this is pretty safe to do, obviously. As the project grows, maybe something like this wouldn't be as safe to do. But for the present, this works. And let's actually, this returns a optional, I believe, or an option, yeah. It returns an option of type map. So let's match on that. In the case of none, let's just print still loading. And then in the case of some, we can get our file data out. Hey, look, it's the same name that we were using before, basically. I wonder what we're going to use some of this other data for. So let's go ahead and grab what we set aside before earlier. So this is created, just a review, this is creating a document using the file data and trying to parse it. If it can't parse it, it'll panic. It then finds the data element, which is this right here, and grabs its text to print to the screen. Simple as that. So let's just replace that file data with this file data. Let's get rid of this ugly comment. Let's make sure we register this in our systems. Add systems. Let's put it in update for the heck of it. Hello assets. There we go. And let's get rid of this constant that we no longer need. All of that to get rid of one constant. Imagine that. And I do believe we're ready. Let's give it a shot and cargo run it. Oh no, we have a bug. I'll kill that. We need a pointer to this, don't we? Yes, we do. We need more than just a pointer to this. We need a pointer to the string inside of it. So we can't document parse off of our struct map. We have to actually grab .0 to get the string out of it, and then turn that into a pointer of a string. And there we go. No longer do we have a compiler bug. Cargo run. Catch you in a sec. We got the data for the map. Logging a whole bunch. Every update. Let me just kill that. Alright. Finally, let's go ahead and break this out into a different file. Make our editing experience a little bit more focused. So we're going to go ahead and make a map loader.rs here. And in order to pull this in, we need to define a module and use that module. And all of this stuff we've added today, we can go ahead and plop that into map loader. Basically all the stuff we've added today. And let's actually define our own plugin for some of this other stuff as well. So that way we can do some of this in that file as well. I'll start by grabbing all of our structs that we made. Not all of them, some of them. We're going to keep our map handles. Plop those in there. Let's define a plugin. So to do that, this is the same system that Bevy uses for default plugins. We're just going to make our own called pub struct. It's got to be pub. Most of these are going to have to be made pub like in a second here. Map loader plugin. And we're going to impl plugin for map loader plugin. And that's going to require a function build with a reference to self. And we're going to take the app, use app. And then in here, we're going to do the initialization of that asset type and also register the asset loader, the map loader. We're gonna send it a set of add plugins, including the map loader plugin from the map loader module that we just made. Anyway, I need to use the Bevy prelude here too, so I can use all the Bevy stuff. Make some of these things public so that they can be seen by our main file. Map loader, however, is only really going to be referenced here, so I don't really care too much about that. I also need to make this value of the tuple also pub. And that should be pretty well broken out. And the reason I'm breaking this out is because our next steps are going to be to grab all of this data and save it in a structure. And after that, we have to link to all these other file types, which includes our templates and our tile sets. And we're going to have to save those also. So that's going to grow this file pretty large. So having this broken out is going to be really helpful for us. But that all is going to happen in the next episode. Thanks for watching. Peace.